Hey guys, hey, we're going to do another sample problem here, or actually, we're going to explain how to do from practice sheet number 2, problem number 4. So let's go ahead and change this to a 4, and we'll go ahead and go through this again. Here are steps that we're going to go through in order to make sure. So we're going to go all these steps. Notice that when we get to convert from grams to moles, that's when we're going to start the molar mass, or we're going to start the stoichiometry problem using the molar mass. Then we have to use our molar ratio, and then we have to go back to our molar mass. Now, we can calculate the molar masses at the beginning, or we can kind of wait as we get there. I like to wait as we go along, but the first thing we need to do is write our skeleton equation. Well, in order to write our skeleton equation, we also have to put in or write out the formulas. So we have to make sure that we know the nomenclature. So let's go ahead and read the problem. And it says, when antimony 3 oxide reacts with elemental carbon, the reaction yields antimony metal and carbon monoxide. So determine the mass of antimony produced when 0.46 grams of antimony 3 oxide reacts with an excess amount of carbon. Now again, when we say excess, that just means there's as much as we need. We don't have to worry about carbon. There's no limiting reactant with the carbon. So let's go ahead and figure out the first thing is when antimony 3 oxide. Now antimony, by notice they have the Roman numeral 3, that tells us it's a type 2 metal, and the Roman numeral is the charge for that, so we know that that's going to be a plus 3. Let's get over to oxygen. We got oxygen. If you haven't figured it out by now, oxygen is a negative 2, but how did we get there? Well, if I go to the periodic table, it's in group 6A, which means it needs 2 electrons to be stable. So it's going to take those 2, and that's why it's going to be a negative 2. Or sometimes we can go down in this right here and scroll down just a little bit, and just not quite halfway, I think. Get to it. To this page right here, and we look at oxygen, and we have it already listed there. So on this page, we already have oxygen listed as a negative 2. So let's go back to our thing, and we know that that's a negative 2. Okay, they do not cancel each other out. So what do? We crisscross them, and we're going to say that we have to have 2 antimonies for every, and I'm just going to make this a little bit wider here, for every how many oxides? 3. So we're going to put a 3 down there. So when I go ahead and write in our balance or skeleton equation, we have antimony 2, oxygen 3. But what's the symbol for antimony? Do you know what it is? Hey, let's go take a look. So let's go back to our packet, scroll up to the top, and we can, all we have to do is find antimony. Now antimony is going to be over on this side. Does everybody see it yet? Antimony, do we see it? Do we see it? Okay. Has we found antimony yet? Oh, right there it is, right there in the middle. Okay, antimony is SB. So let's go ahead and go back. We know that we're going to have SB, and then we're going to have 2 of those. Okay, then we have oxide. Oxide again is oxygen. So we're going to put oxygen, and we have to have 3 of those. Now that's going to react with elemental carbon. Okay, so we're going to add our plus sign in there, and we're going to do carbon. Now again, anytime that we have an element by itself, we have to ask, is that element diatomic? So let's go ahead and go back to the periodic table. Diatomic elements make a 7 right here, and carbon is not one of those. So it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and over here, hydrogen. Carbon is not one of those, so we go back and we can leave it just like that. So we're going to, that's going to react. It's going to react to produce what? Antimony metal, which is going to be SB. Now, is it diatomic? No, it wasn't one of our 7, so it's not diatomic. And the last one is carbon monoxide. Carbon monoxide, it is a type 3 compound, so that's how we name that. There's no prefix in the beginning of carbon, so that means that we only have 1 carbon. And then mono, the first part of that monoxide, means that there's only one oxygen, so it's going to be CO. So there is our skeleton equation. We have that all ready to go. So now what do we need to do? We need to balance it. That's what it says right here. We need to balance it. Step 2, balance the chemical equation. So we're going to do that by coming down here, and we're going to put on what we have each one. So I have antimony, I have oxygen, and I have carbon. Okay. And how many of each one do we have? Antimony, we have 2, so we're going to put a 2 there. Oxygen, we have 3, so we're going to put a 3 there. And carbon, we have 1. Now, I like it when there's no numbers here, and no, because we're not going to worry about anything except for the ones that aren't all by itself. So we don't have to worry about carbon. So we're going to come over into this side, and we're going to say we have antimony, we have oxygen, and we have carbon. So on this side, how many do we have? We have 1 antimony. I like that. We have 1 oxygen, and we have 1 carbon. So what's the difference? Well, our antimony and our oxygen is different. Well, since antimony is at the end here, and it's all by itself, I'm not going to do that. I'm going to do the oxygen first. Carbon's by itself, but that one's already matched up. The antimony is all by itself, so whatever coefficient I put at the front of it, it's going to be balanced. So we're going to have 2 antimony here, or we're going to do oxygen. So I have 3 over here, and I have 1 over there, so I need to put a 3 in front of that. So I changed my oxygen to 3, and we'll go ahead and get rid of that. And what else did it change? It changed my carbon. So it changed my carbon to 3. So I'm going to go ahead and put that over and put a 3 there. So I'm going to get rid of this. Okay, so now we have our 3, 3. But my antimony and my carbon is different. So let's go, it doesn't matter which one we do. Let's chase the carbon. So since I changed this one, we're going to put a 3 right there, which changed this to a 3. Okay, so we got to get rid of that. And now the only thing different is my antimony. So I'm going to put a 2 right there, which now that means I have how many antimony over here? I have 2. We'll get rid of this. Okay, now we're balanced. It looks like I have 2 and 2, 3, 3, 3, and 3. Let's double check. 2 antimony here, 2 antimony there. 3 oxygen here, 3 oxygen there. 3 carbon here, 3 carbon there. Looks like it's good. So what is our molar ratio? Is going to be 1 to 3 to 2 to 3. Okay, and again, I like to go ahead and change that so we know what it is. And then we always ask ourselves, can I reduce that? Well, because I have the 1 in there, we can't reduce it. So there's our balanced chemical equation. So our next step that we have to do is we have to start our stoichiometry, and we're going to start with the mass in the problem. So where's the mass in the problem? Well, it's right here. Okay, 0.46 grams of antimony oxide, or antimony 3 oxide. So we're going to go ahead down here, and we're going to start right there with 0.46. Now, if you don't want to put the 0 in, that's fine. Just put 0.46, and then we're going to do antimony 3 oxide, which is what we've calculated out to be right here. So we're going to go ahead and copy that, and we'll paste it right there. Now, again, remember, what do we do after that? We're always going to put our handy-dandy times, and a line. Okay, and we're going to do this for each one of those steps, and there are 3 steps. So once we put this down, we're going to have 3 times in a line, okay, in order to get from mass to mass. Okay, so what are we going to do on the bottom? Oh, we got to also put that is grams. So we're going to put grams on the bottom. So actually, I'm going to just copy this right here, copy that, and then once I get over there, I can paste it. And we got to figure out what is the grams that goes there. Now that's the molar mass, because we have to get to the number of moles. So on top, we're going to put 1 mole, okay, of antimony 3 oxide, and we can get rid of the grams. So we have that, and we're going to just go ahead and underline that, like we always have to do, because we do times in a line. That's our line. Okay. And then we're going to do our another times in a line, and we're just going to get rid of the underline on that part. So we're going to figure out the molar mass of antimony 3 oxide. Okay. So I'm going to come down here and I'm going to paste what we're going to do. So we're going to do this one right here, antimony 3 oxide. So how many antimonies do we have? We have antimony, and we have 2 of them. And we're going to times it by its atomic weight, which I don't know what the atomic weight is. But then we have oxygen. And how many oxygens do we have? We have 3. We're times it by its atomic weight, which is 16, because I do know that one. And we're going to figure out what that equals. I believe it's 48, but we will double check that because we always should double check that. So let's go back to our calculator, or back to our periodic table, and see what the atomic weight of antimony is, so we can put it right there. So let's go back to there. Antimony was right here, so it's 122. So the atomic weight of antimony is 122, so we're going to come back, put that right there, 122, which means that when we multiply it by 2, we're going to end up with 244. Okay, and we should be able to double check that. So let's pull those up, get the calculator, and let's just go 2 times 122 equals, that's correct, and go 3 times 16 equals 48, so that's correct. So we're going to go ahead, and our molar mass is going to be equal to those added together. Okay, so we're going to add those together, and we're going to end up with, and let's just go ahead and add them together, 244 plus 48 equals, let's double check that's not right, 244 plus 48 equals, there, that looks better, 292. But again, let's go ahead and double check that, 244 plus 48 equals, there we go. And that's going to be what? It's going to be grams of antimony 3 oxide. So we're going to put down grams, and then we're going to go ahead and paste our next antimony 3 oxide. Now that's the molar mass. So we know that that's going to be equal to, again, this is going to be equal to 1 mole of antimony. Okay, and I didn't need to put that down there, not grams, but 1 mole of antimony 3 oxide. But it's nice to know because this is my conversion factor. So this is why I have this on top and this on bottom, because I converted from grams of antimony 3 oxide to moles of antimony 3 oxide. So we're going to take this 292 and we're going to place it right here. So 292. Now I always want to know, what can I get rid of? I have grams of antimony 3 oxide here. I have grams of antimony 3 oxide there. So we're just going to go ahead and get rid of those. Okay. So now that we got rid of those, I'm in moles of antimony 3 oxide. If we go back up to our thing, now we have to use our molar ratio to convert. So now we're going from 1 to how much metal, right, determine the mass of the antimony, to 2. So since I have 1 mole, or I have moles of antimony 3 oxide here, I need to put moles of antimony 3 oxide there. So I'm just going to go ahead and put down 1 mole, and then I'm going to paste what I already have done of that and get rid of the grams. And we know that on top we're going to put down 2 moles of antimony. Okay, and we're just going to go ahead and underline that. Okay, and then what I can do is we're going to do times and a line again, but I'm going to get rid of now my moles of antimony 3 oxide because I have that on top and bottom. So we're going to go ahead and get rid of that. And I'm left with moles of antimony. Well, I don't need it in moles, I need it in grams. So again, to change from moles to grams, we're going to use molar mass again. And again, that hint is up here and this here. So to convert from moles to grams, we've got to use molar mass. So we're going to put down molar mass. We know that 1 mole equals the molar mass of this antimony. So we're just going to go ahead and we're going to tap that over. We're going to say that 1 mole of antimony, that's our bottom. But what are we going to put on top? We're going to put the molar mass of antimony. Well, in this case, it's just SB, so we know that one of them weighs 122 grams. So we're just going to go ahead and put that up there. So I'm going to take this and we're just going to put 122 grams of SB. So we don't have to figure it out. It was already there. It was in the periodic table. So we're going to go ahead and underline. And then what can I get rid of? Again, my last thing, because I can have to have it left in something, okay, in grams of SB. Okay, so we're going to go ahead and we're going to get rid of moles of SB. So let's get rid of moles of SB. I have it on top and I have it on bottom. Okay, that leaves me with grams of SB. Now, is that what it's actually looking for? I always, again, go back up to the equation, and it says determine the mass of antimony produced. Well, that's antimony was produced right there, so that's SB. So we got to figure out this. So how do we do that? Again, we bring in our calculator. Okay. Let me move the calculator over here. Clear the calculator, and we multiply. We take our numbers, we multiply by the top, divide by the bottom. But again, if it's 1, we do not have to do that. So let's go ahead and do that. We're going to go 0.46. We're going to divide that by 292. Then we're going to multiply that by 2, and then we're going to multiply that by 122. That's going to equal 6.456. And let's just go ahead and put that 6.456. But we need to double check it. Always have to double check it, okay? So 0.46 divided by 292 times 2. I didn't times it by 2, did I? Okay, let's go back. Let's clear it again. Let's start it over like we always do. Everybody, we always make a mistake. So 0.46. 46, let's get it right. Divide by 292. Multiply by 2, then multiply by 122 equals, there, that's a different answer. Okay, I didn't think that one looked right. This one looks better, but let's double check and make sure that we're the same. Okay, so let's clear that and go 0.46 divided by 292 times 2 times 122 equals, there we go. So let's get rid of this answer. Pull back up our calculator and see it's going to be 0.38438. 0.38438. Yeah. Double check with the calculator. That looks, nope, I have 4.6. This should be a 3. Right? 3, 4, 3, yeah. And there would be a 3 after this if I wanted to. But I don't need all that, because what do we have to do? We have to round to the correct number of significant figures. If I go back up to the problem and we read the problem, right there's our number right there. And that's only 2 significant figures, because preceding zeros are never significant. And again, you have to know that. So I need to have 2. So this one's not, this zero is not significant. So we're going to go 1, 2, 2. There we go. So we're going to put our number right there. The 4 says, we always look at the number after it. The 4 says we drop it off, so we're just going to get rid of those. And there we go. 0.38 grams of antimony metal is produced when we start off with 0.46 grams of antimony 3 oxide within this equation. Hey, hopefully if this helped you out. And as always, go Mohawks. Nelson out.